Hello everyone and welcome to this course on Basics of Electronics. My name is Dr. Mrs. Rajashri Anwani. I am an assistant professor in physics in the Department of Basic Sciences and Humanities at St. Vincent Pallotti College of Engineering and Technology. In this course on Basics of Electronics, I'll focus more on PN junction and its applications. So what is a PN junction diode? It is a solid state device. A solid state device is a device, or solid state devices are those which are made from semiconductors. Now what is a semiconductor? Semiconductor is a material whose conductivity is more than that of an insulator and less than that of a pure conductor or a metal. There are two types of semiconductors: intrinsic semiconductors and extrinsic semiconductors. Intrinsic semiconductors are also known as pure semiconductors. The most commonly studied intrinsic semiconductors are silicon and germanium. Silicon with atomic number 14 and germanium with atomic number 32 both have a valency of 4 each. Extrinsic semiconductors are those which are made from intrinsic semiconductors by doping them with the impurities, either pentavalent impurities or trivalent impurities. When the pentavalent impurity, for example phosphorus, is doped in an intrinsic semiconductor, we get an N-type semiconductor. When a trivalent impurity like aluminum or boron is added in intrinsic semiconductor, then we get a P-type semiconductor. So intrinsic semiconductors, and then there are two types in extrinsic semiconductors: a P-type extrinsic semiconductor and an N-type extrinsic semiconductor. The P-type extrinsic semiconductor is the one in which the holes are majority charge carriers and the electrons are minority charge carriers. The majority charge carriers are those which are very large in number in a particular semiconductor, and the ones which are very less in number are known as the minority charge carriers. The name P-type suggests you that the majority charge carriers are positive, hence the name P-type semiconductor. Similarly, in N-type semiconductors, the majority charge carriers are electrons and the minority charge carriers are holes. Now, the properties of intrinsic semiconductors and extrinsic semiconductors vary, and that is why they have different applications. The properties of extrinsic semiconductors, P-type and N-type, depend on temperature as well as on the concentration of element added to form a particular extrinsic semiconductor. When the temperature of an extrinsic semiconductor is increased beyond the room temperature, the current through the semiconductor will rise. So and so, when the doping concentration of an trivalent or pentavalent impurity is increased in a particular semiconductor, then also the current will rise. And the applications of these devices which are made from extrinsic semiconductors are very large, and we are going to see into those later on. So what is a PN junction diode? Why there is a need of a PN junction diode? When we see the individual behavior of P-type or N-type semiconductor, then we can see here that the behavior is ohmic or linear. Here, for example, I have shown a P-type semiconductor connected in both the ways. So when you can see, when it is connected like this, when we increase the voltage, the current also rises linearly. So and so, when the voltage is decreased, the current also decreases linearly. So this is known as the linear behavior or ohmic behavior. So any individual extrinsic semiconductor will behave linearly, and this is of no use because this is very similar to the behavior of a resistor. That is why a PN junction diode is formed, which is of more use. So how is a PN junction and hence a diode is formed? The figure to the left shows you the formation of a PN junction, and the figure to the right of this small figure shows you the picture after the junction is formed. The figure here shows two blocks of silicon doped uniformly, one with acceptor impurities, that is the P-type, and one with donor impurities, that is N type. The trivalent impurities are also known as acceptor impurities. The pentavalent impurities are also known as donor impurities. The p region consists of a very large number of holes which are shown by small circles which are hollow, a very few electrons, and the larger circles which are hollow, they denote the ions. So, the p type region has a very large number of holes, very small number of electrons, and immobile negative acceptor ions. The N region consists of a large number of free electrons which are shown by the filled circles, a small number of holes, and a large number of immobile positive donor ions. Both the blocks are electrically neutral as the charges of the ions are neutralized by majority carriers. So, when we see the behavior of p-n junction diode now with respect to the bias voltage applied externally, you can see the behavior is very different from the individual p-type semiconductor. The figure to the left shows you the behavior of a p-n junction diode when it is connected to an external bias. So, when the connections are like this, the positive terminal is connected to p, negative is connected to n type, then you can see a non-ohmic behavior. And when the p-n junction diode is connected such that the negative terminal is connected to p region and positive is connected to n region, you can see a very small current flows through the diode. So, when the p-n junction diode is connected to the external bias voltage, then it shows a non-linear conduction. It allows current only in one direction, that is in forward direction, and opposes the current in the opposite direction. This property of the diode is known as the rectifying action. It is a very remarkable property of the p-n junction diode and it is known as rectifying property or rectifying action. It is widely used in rectifiers which convert input AC voltages to DC voltage. Practically, all semiconductor devices contain at least one p-n junction. The production techniques enable the fabrication of p-n junctions to suit specific purposes. Thus, a varicap that acts as a variable capacitor, a tunnel diode and a gun diode as oscillators, a Zener diode as a voltage stabilizer, a photodiode as a light detector, a solar cell as a voltage source, an LED and a laser as light sources are all p-n junctions. A junction transistor and a phototransistor are fabricated with two p-n junctions in close proximity. Thus, a p-n junction constitutes the most basic component of solid state devices and a thorough understanding of its electrical behavior is essential for appreciating the operation of many semiconductor devices.